Hi everybody, so in this video I'm just going to give you a quick walkthrough on how you might find the x and y intercepts of a parabola. So in the example here you can see I've got a simple parabola, x minus 3 all squared, take away 1. And just graphically to walk through and see how you might work this out, we know that the x minus 3 is actually representing a shift of 3 to the right and the minus 1 is a shift of down 1. So we know that's going to be sitting at the vertex, or the turning point is going to be sitting at 3, negative 1. And you can see there is nothing here, there's no coefficient of x squared. So right there is nothing, which means it's just an ordinary parabola. So that's going to have our basic shape across 1, up 1. So from that vertex down the bottom here, I can go across 1, up 1, and there's my next point. I can also go across 1, up 1 in the other direction because it's symmetrical. Similarly, I can go across 2, so 1, 2, and then up 4. 1, 2, 3, 4. Now clearly this is not the neatest, but it will do. And I can also go back 2 and up 4. And I will get this nice parabolic shape. Beautiful. So that's my basic curve, and you can see it's pretty straightforward in this case to work out where the x-intercepts are. And if I wanted to work out my y-intercept, I could of course say, well, I'd need to go across from the vertex 1, 2, 3 places, and that means I need to then go up 9 because it's an x squared. So that will take me from negative 1 up to 8. 1, 2, 3, 4, 5, 6, 7, 8, somewhere up there. There's the rest of my curve. And so I can sort of see there's my y-intercept at 8, my x-intercepts appear to be at 2 and 4. And so that's a nice way of working it out graphically, and sometimes it'll be really straightforward to see that. However, it's nice also to be able to do this with algebra, and so I'm just going to walk you through how to do that as well. So what you need to understand, of course, is on this x-axis down the bottom here, every single point along that line, all the way along here, has a y-coordinate of 0. And because all the points on our line must obey this rule that we've got at the top here, they all obey that rule. If we know that a point has a y-coordinate of 0, we can actually put 0 into that equation and use that to work out what the x-coordinate must be. So here we go. So to get the x-intercept, I am going to make y equals 0. So I'll just write y equals 0. So we have 0 equals, and then we have this x minus 3 all squared minus 1. So now it's just a straightforward equation to solve. So we can rearrange it. I'll take the 1 across, x minus 3 squared. Let's take the square root of 1. So square root of 1 is equal to x minus 3. Now remember, the square root of 1, that is going to be either plus or minus 1 because it's a positive number, so we'll have two solutions. So there's x minus 3. And now, so when we rearrange this equation to finish solving it, I'm just going to have to add 3 to both sides. So I'm going to end up with x is equal to either positive 1 plus 3, which is equal to 4, but it also equals negative 1 plus 3, which is equal to 2. And you can see these two solutions, 4 and 2, match what we had over here on our graph. So that's how you could algebraically find the x-intercepts. So we can use exactly the same technique to find the y-intercept. So if you think of the y-axis over here, my y-axis, you know every point along that line has an x-coordinate of 0. So we can use that exact same knowledge to try and solve this too. So I'll just do this down below here. So to find the y-intercept, we know that x is equal to 0. So we can just substitute that into our rule. So we can say, well, y is equal to 0 minus 3 squared minus 1, which is going to be equal to negative 3 squared minus 1. Now negative 3 squared is 9, so 9 minus 1, which equals 8, which is also, if you notice, what we got here on our original graph. So I know all we're doing here is just confirming what we did visually with our graph, but it is also very useful to be able to do this because in the future there will be problems that don't solve quite so nicely. So anyway, that's just a quick walkthrough on how you might find the x and the y intercepts of a parabola.